Hello students, today we will see about physical interpretation of psi star psi. The Schrödinger thought psi as a particle. Okay, he assumed like that. And also this particle has matter wave like other sound waves and water wave like that. Okay, so this matter wave is according to de Broglie. But this interpretation had many difficulties. Point number 1. Particle is located but wave is non-localized, which means when we try to locate the particle, we find them in a small region. Okay, then only we can able to find where the particle is located. But a wave function psi at a given time spreads like a wave. So with respect to time, we couldn't localize that waves. Okay, so it is non-localized. Point number 2. For one particle, we interpret psi as a wave in space and time. But we consider n number of particles. The wave has to be represented as a three-dimensional space. Point number 3. Psi as a complex value, but interpretation will be given for real values only. We couldn't interpret the negative value. So we need a new interpretation. So in this interpretation, psi is related to the presence of particle. In the previous interpretation, we see that psi as a particle, not a presence of particle, but the new interpretation, psi is related to the presence of particle. If psi value is 0, then the particle is not present in the region of space. Okay, if psi value is non-zero or not equal to 0, then we can say that the particle is present in the region of space. In 1926, Max Born considered the collision between two particles. He used the perturbation theory and formulated a formula like this: scattered wave. Here, phi f is a final stationary state solution after collision, and phi I is the initial stationary state of the solution before collision. Then modulus of Cfi square is the number of particles scattered with the final state and initial state. This is very important. Here the Cfi square is the number of particles scattered. Okay. But here he assumed that a potential barrier which has the property that 60% of wave will be reflected and 40% of the wave will be scattered. If we consider one particle incident on a barrier, then here can we apply this property, that is 6% of the one wave is reflected and remaining 40% of the wave will be scattered? No. We couldn't split that single particle. That means a single particle cannot divide itself. So that above consideration is wrong. Then the Born assumed Cfi square is the probability amplitude. Then he interpreted psi star psi as the position probability density. Okay, here P into, that is probability, dx, dy, dz be the volume element, that is d tau. So P into dx, dy, dz is the probability that the system will be in the volume element dx, dy, dz at the position x. So psi itself cannot be a probability because psi value will be complex and negative, but the probability value should be in real and positive. So if we take the multiplication of the psi star and psi is equal to x plus iy is a complex number, and psi star is equal to complex conjugate of the wave function, so x minus iy. If you multiply that, what we get, x square minus I square y, that I square will be minus 1, so we will get x square plus y square. So the final conclusion is psi has no direct physical meaning, and psi star psi has the physical meaning. Okay, so see here that in this picture, that psi naught value will be here, and if we square that, we will get like this. So psi 1, see, one is negative, another one is positive. If you take that complex conjugate and multiply, we get the same side. So we can see that here that value will be that real and positive. So to make it that, we will take that psi square. Thank you, girls.